All right, so let's go through the rest of these at a much quicker pace here. First one, number 11, we got calcium hooking up with a bunch of elements here. We got a sulfur and then 4 oxygens. So you should recognize that there's a metal, calcium, and use your periodic table. Calcium's over here. Oops, I don't want to do that. I want to write. So calcium's over here. It makes a +2 charge. You have to know the charges. So put a +2 up here. And then the nonmetal, or the anion, is all the rest. More than one element, so that's a polyatomic. It's 1 sulfur and 4 oxygens. You cannot take that 4 and put it anywhere else. It has to go with the S and the capital O. Hopefully this looks like a capital O to you, not S little o. That's something different. All right, so SO4, you have to recognize that that's sulfate, because if it was plain S, it'd be sulfide. If you don't know what the charge is, look it over here. Sulfate with a -2. You could look back in your notes. I don't care where you look. Sometimes you might memorize these, but this is calcium with sulfate. Given away 2, gaining 2. That's why it's a 1-to-1 ratio, 1 of each. And we just name the metal, calcium, and it's not one of those guys that makes more than 1, so no Roman numeral, and then it's sulfate. The next one, again, we have calcium, but after that, we only see an S. So it's sulfur. Look on the periodic table, sulfur's over here, makes a -2 charge. That means it wants to gain 2, which is perfect, because that's exactly what calcium wants to give up. So one of these makes one of these happy. So that's why it's a 1-to-1 ratio. No little numbers down there. Notice it's not Ca2S2. We don't do that. It's a 1-to-1. And what do we write? Calcium and then sulfide. If it's a normal element off the periodic table, we change the ending to "ide." All right, NH4. This is more than one element, neither of which are a metal, but it acts like a metal. This is a cation, and we call this cation ammonium. This is the only one that we're going to deal with. There are others, but it's the only one that we're going to deal with that gives away electrons and makes a positive charge. All the rest take. So ammonium, what is it hooking up with? Chlorine. We change the ending to "ide," so it's chloride, ammonium chloride. Now we look at the ratio. This is trying to give up 1. This is trying to get 1. That's a 1-to-1 ratio, so we write one of these and one of those. No parentheses, because it's 1-to-1. The next one, it's still ammonium, but in this case, it's hooking up with P, which is plain old phosphorus on the periodic table, so we change the ending to phosphide. And then we have to look at the formula for this. So we're going to write NH4, that's one of our ions, and it's going to bond with P, and now we do the crisscrossy thing. The 3 from the P is going to be written after the ammonium. Now the ammonium is NH4. If we're going to write a number after it, this formula has to go in parentheses. So wrap NH4 in parentheses, then put the 3 there. Now the 1 from the ammonium goes after the phosphorus, so we don't write anything. That 1 normally doesn't get written. So it's NH4 in parentheses and then a 3, because we want 3 sets of those, and then P. All right, the next one. I see a Roman numeral. I love Roman numerals, because that means I don't have to look at the periodic table. Fe plus 3. That's the charge. Sulfide is really sulfur from the periodic table. What charge does sulfur make? We already saw it makes a -2. I need to know this, -2. So this is sulfur, -2. That's not a 1-to-1, so I crisscross. It's going to be Fe2S3. This is iron 3 still, Fe plus 3, but now it's hooking up with sulfate. 8 is different than ide. 8 is more complicated. It's one of those parties. Sulfur's hanging out with oxygen. How many? We don't know unless we look it up. Oh, there it is, SO4 with a -2. So there's 4 oxygens hanging out with sulfur. You got to write that, and then a -2 to let you know how many it gains. So iron's trying to give up 3. Sulfate is saying I can only take 2, but I'll find some friends. We crisscross them, and we end up with Fe2, and then write the formula for sulfate. 1 S hanging out with 4 O's, and then the 3 is going to be written after that. So you got to wrap the formula for sulfate in parentheses and then put a 3. Aluminum hydroxide. Aluminum is a metal. look up on the periodic table what aluminum does. Here's aluminum, look up, plus 3. So aluminum's trying to give up 3. And it's hooking up with hydroxide. Now, I normally tells you look on the periodic table. But in this case, it is a polyatomic ion that you need to know. Hydroxide, OH, -1. So we put OH, -1 here. So these two are going to crisscross because they're not the same. The 3 goes there, the 1 goes there. So we write Al. Then we write the formula for hydroxide, OH. And now I want to put a 3 after it. This is a polyatomic. I don't care if the polyatomic has numbers in it or not. You still have to wrap it in parentheses and then put the 3 there. If you don't wrap it in parentheses, you're going to show that it's Al bonding with an O and then 3 H's. That's not what we want to show. It's not ALO HHH. It's 3 of these OH's. OH, OH, OH. So 1, 2, 3 of them. All right, the next one, we write the name magnesium. We know it's Mg. We look on our handy dandy periodic table, find magnesium, look up, +2 charge. Oops, +2. Then who's it bonding with? P, that's plain P. It's not P having a party. We look on the periodic table. What's P doing? P is making a -3 charge. Those are our 2 ions, and this is magnesium phosphide because it's plain old P. Over here, we got magnesium hooking up with phosphate. So again, magnesium makes +2. Phosphate is P having a party. It's hanging out with oxygens. How many? I don't know, so I look it up. PO4, and they have to gain 3 electrons. So that's the formula, gain 3. Now, they're not hooking up on a 1-to-1, so we crisscross it. So it's Mg with a 3. 3 goes there. And then the 2 is going to go after the phosphate. So write the formula for a phosphate. And if you're going to write a number, which we are, we're going to put a 2 over here. Wrap that in parentheses. Magnesium phosphate. Chromium 2 oxide. Chromium symbol, Cr, +2. It's hooking up with oxide, which is really oxygen. Oops, -2. How do we know that? It's oxygen. Always makes a -2. You just memorize that. So giving up 2, gaining 2, that's a 1-to-1 ratio, CrO. Over here, same 2 elements, but now chromium makes a +3 charge, oxygen still, and will always make a -2. That's not 1-to-1, so we crisscross Cr2O3. The next one, I recognize my metal. That's magnesium. Magnesium we dealt with already. We know it's +2. If I didn't know that, I checked my periodic table. My non-metal is everything that's on the right of magnesium. So it's CO3. It's more than one element. It's a polyatomic. I just have to look up what this is, what we call it, and what the charge is. It's carbonate. CO3 with a -2 charge. That's carbonate. So magnesium given up 2, carbonate taken 2. That's why it's a 1-to-1 ratio. Notice that you see the formula for 1 magnesium and then 1 carbonate. No parentheses, no numbers after it. So we just call it magnesium, and then you state the name of the polyatomic. Oops, carbonate. Next one, copper hooking up with nitrate. Copper's making a +2. I love Roman numerals because I don't have to look at the periodic table. Nitrate, that's 8 endings, so it's N having a party. How many? I don't know, so I can look it up. Nitrate is right here. NO3 makes a -1. Then I crisscross because it's not a 1-to-1. The 1 comes after the copper, so I write Cu. The 2 goes after the nitrate. I'm going to write a 2 after nitrate. If it's a polyatomic, which it is, I wrap it in parentheses, put a 2 there. And then finally, aluminum hooking up with sulfate. This is not a 1-to-1, so I crisscross. The 2 comes after the aluminum, Al2. The 3 is going to go after the sulfate, so I write the formula for sulfate, and then I realize I'm writing a 3 next, so I have to wrap the formula for a polyatomic in parentheses, then write my 3. This is aluminum sulfate. So you always need to know the formulas for the the charges for the ions. Then you have to check to see if you crisscross them. If you do crisscross them and it's a polyatomic and you're going to write a number after it, put it in parentheses. Even if it's OH, it has to be wrapped in parentheses if you're going to write something after it. But if I'm just going to write 1, like if I'm doing sodium +1, hydroxide -1, I don't write it in parentheses. I just write Na and then one of these, OH. Okay? When you name, just take a peek at the periodic table to see if it's one of those elements that makes more than one charge. If so, use a Roman numeral. I didn't use one here because magnesium only makes one charge. Over here, we would have to use a Roman numeral because copper makes more than one charge. How do you know that? It's on the periodic table. You just have to look when you're figuring out what's the charge on a metal. If you see more than one charge in the box, you've got to write the Roman numeral that matches the charge. If I was writing a formula for zinc and I look in the box because I'm not really sure, does zinc make more than one charge? I don't know, let me look it up. And I only see a +2, well then I don't have to write a Roman numeral there. I just write zinc whatever. If it bonds with oxygen, zinc oxide. But if copper's bonding with oxygen, then I've got to write a Roman numeral because it makes more than one charge. All right, so hopefully we've got this all together. If you struggled at all, ask for help. Make sure you go through these flow charts. They tell you what to do step by step. So if you are feeling a little lost or you feel like you need some more practice, go back through all of the notes, pick a few examples, and walk through the flow chart until this becomes automatic. If this flow chart is not automatic, then you're not in a good place yet. You need more practice.